Okay, let's start with the job sequencing problem. So, currently I'm going to explain the job sequencing problem from the Geeks for Geeks website. So, what is the problem statement? Firstly, let's look at it. We are given an array of jobs where every job has a deadline and associated profit if the job is finished before the deadline. Okay, a very important assumption that we must take care of is that every job takes a single unit of time. Okay, so the minimum possible deadline for any job is 1. What does that mean, minimum possible deadline? That means that given some job, okay, given any job here, we are already assuming that it takes a single unit of time. Assume it took some more units of time, let's say 3 or 2. Let's say some job takes 3 units of time. There is a possibility of job taking 3 units of time. So can the minimum possible deadline be 1? That is, can some job, okay, listen, can some job be scheduled in 1 unit of time? If we were saying that the minimum possible unit of time, let's say, were 3, were 3. No, because one job cannot be completed in 3 unit of time, in 1 unit of time, because already that job takes 3 units. All right. So it won't get completed. So minimum possible deadline in that case would have become 3. So this assumption is given. Now what we have to do is maximize the total profit. Uh, only one job, if only one job can be scheduled at a time, right? At a time we have to schedule a single job, and we have to like find the maximum profit in which we can schedule these jobs in the given deadline. Okay, right. So that is the question. So what we can do, what we are supposed to do, what approach we are supposed to take here is that firstly, we should sort these according to their profits. Why? Why should we sort them? Because we ought to maximize the total profit. That is the most important goal. And we have to respect the property of deadlines. That is, those jobs should get completed in whichever deadline they are associated with. Like here it is given. Okay, so what we did is we have sorted them according to profits. Okay, so it will go accordingly like C, C, D, A, B. This is how it should go, right? After we have done that, what we will do is in our job sequencing algorithm, we'll start from the maximum profit in the descending order. Start from the maximum profit, check the associated deadline. Okay, check the associated deadline, and we will check whether we have already slotted it. If we have slotted any job at this given deadline, then we won't slot. We'll go one less, one lesser. Why? Because let's say some job is getting slotted in, let's say, for example, three deadline. It has a deadline of 3 slot. So that job can as well be scheduled at deadline 2, as well be scheduled at deadline 1, right? So we can schedule some job earlier than the given deadline, but we can't go past the deadline. That is the crux. So what we ought to do here is we'll schedule whichever maximum job is at that given deadline. We'll check whether that slot is available. If available, then we'll slot this. We'll directly slot this, and then go ahead. Go for the next maximum job, next possible uh, greater profit job. So that ought to be D 30. But now it is 1. We have already scheduled the job at 1. So what can we do? Next profitable job. That should be A. Now A has a deadline of 4. Yes, we can schedule it at 4. So we'll directly see whether something is scheduled at 4. No, we'll schedule it at 4. Okay, we schedule that at 4, slot 4. And then we'll go to B. Now again B can't be scheduled. So 1 is already having a slot of C. So that is how we get a C and an A. C and an A. In the similar way, I'll show you for this example. So here they are given profits. Okay, so what we sort accordingly, like A, then comes C, then comes D, B, and E. All right. So after we have done this, what we'll do is first check, that is we are traversing the jobs. Okay, what we have done, firstly we are traversing the jobs according to their profits. We have already sorted them. So firstly we'll go check job A, check whether the deadline 2, the slot 2, is whether it is occupied. No, because it's the first job and it is already a profitable job. So we'll schedule it at slot 2. At slot 2, A gets scheduled. So assume A is here at slot 2. Then after that we go for the next profitable job, which is our C. Okay, now C. Now this C has a deadline of 2. Now we'll check for the slot 2. No, slot 2 is not available. Now what can we do? We can slot it at a previous slot. So we'll check 1. The slot 1, yes, it's available. Nothing is there. So C gets scheduled at slot 1. Alright. After C gets scheduled at 1, go for the next profitable job. That should be D. Now D is at slot 1. But we can't schedule it because already C got scheduled. Now we'll go for the next one then. In the same way, we went here. B. Right, B cannot be scheduled. 1 is already occupied by C. Then at the end we reach E, the last job that can be scheduled, the least profit, but it has a deadline of 3. Yes, we can schedule it at deadline 3. So we go on the slot 3, schedule it, and proceed. In that way we would get A, C, and E as scheduled. The order will be like this. Why? Because C got scheduled at slot 1. Okay, well, even if it had a deadline, we can schedule it earlier, as we said. Then we slotted A at slot 2 and we scheduled E at slot 3. All right, so now let's look at the code. I've already written the code for this, assuming it takes 1 unit. We get the size of all jobs, n. N is the size of all jobs, that is basically number of jobs. Then we sort the jobs according to their profits. This is the qsort function, quick sort function available in C language. Okay, you may need to include these standard library functions. Additionally, this qsort function takes a compare function. Okay, now what is this compare function? This is also just actually a something that is part of C language, but I'll explain you. Like, we can basically compare any two type of objects and we write the comparator for that object. So this is how we write. We give it, the answer will always be an int of this compare. Take two variables, x and y, having these are jobs for us currently because we are comparing two jobs. But how do we compare those jobs? Based on their profit. So we return in the descending order of profit. That's the reason I gave J2 minus J1. Now if this J2 minus J1 is, let's say, greater than 1. If it is greater than 1, that means J2 was greater. Okay, so this comparator function will understand that actually this y is greater. It will keep it ahead. Then if it were less than 1, then it will be lesser, like J2 is lesser, so J1 should be written. So J1 will be like kept ahead. So in that way we get a descending order. Okay, now that we have understood that, let's proceed. We sort it and give all these jobs with the length, number of jobs. I've written this C code. So this sequence it function does our work, this array and n. Now what we have to do for the slotting? We have to keep a result array, okay, which will have the list of job IDs, okay, because we are going to output the IDs. As you see here, we are outputting the IDs of maximum profits. Additionally, we keep slots array that has the occupied slots, okay, which slot gets occupied. Then we initialize the slot firstly to false because we want that none of the jobs are scheduled at first. So as we said, first we traverse all jobs. Basically, we are traversing each job and checking whether it can be slotted at that deadline. If not, we have to slot it at a smaller deadline. So we traverse that, and then we check the last free slot and then occupy it if it is free. That's what we did. Last free slot. Going ahead like this. Subtracting it, subtracting the slots, going into the last free slot. Now, what are we doing here? Why are we comparing it with the minimum of n? Basically, we have to find which deadline is less than the size. Like, let's say some deadline was given. Okay, let's say it were some 6 or 7, and we have 5 jobs. Okay, if we already have 5 jobs, we already have 5 jobs. We know that each job takes a single unit of time. All right, already have 5 jobs, and some deadline of 6 or 7 is given. So can like, do we need to reach till the sixth slot, like sixth or seventh slot, sixth or seventh yeah, slot? No, because we already have 5 jobs. So no matter how, each slot will already occupy one space, and we shouldn't waste these like slots, right? Because deadline is already till 5, last minimum deadline basically. Oh, I mean, minimum jobs are only 5. So no matter how you place them, how you place those 5 jobs, they have to get finished in those this thing, number of 5 jobs. So total 5 jobs taking one unit of time. It has to get finished in 5. So basically, we just always take this minimum. Okay, and then we slot it accordingly. So what are we doing? We check whether the slot is false. So the first slot, which slot? The slot of J, that is this, the deadline. So in this deadline, what will it be? We'll start from this because it is sorted in the descending order. Deadline will be 2. So at deadline 2, between 2 and n, now we know that none of these actually deadlines cross the n remark. So we have 5 jobs, right? So we don't need to check that. Mostly it will start from that deadline only. Now we subtract that with 1. Why do we subtract that with 1? Because our starting of the array is from 0 to n. So we get the previous one. Then we check whether the slot is false. Now, if the slot is false, the given deadline of 2, if it is false, that means at slot 2, there is no job that gets scheduled. Now, if that is the case, we schedule it, that is by storing it in the result, that is at jth index, we store this ID, that is A, and we store at the jth slot to be true, that this slot got occupied. That's it. That's all that we store. After that, we go and break this job slotting loop, where we are checking for the slots. That is, we are going in the decreasing order of the slot. Like, let's say that slot didn't occupy, we get to the smaller slot. So that is done. Now we'll go and check for the next job. So currently what we have to do is we have to traverse all the jobs. We have to slot every job, whichever possible job. Next job that we get to is C. Please avoid any noise if it is coming from outside. Okay. C. C has 27. Now C, can it be scheduled at 2? No, this slot will be false. 2. No. So what we'll do is this J will go reduce to 1. Right. It won't start with 2, it start with 1. Then it will go to 0. Now 0th slot, will it be available for C? Yes, it will be available. So we update that to results, result array, and the slot gets filled. Then we go to the next job, that is uh, this this breaks and it goes for the next job in I. So it will be which one? This one, D. Now whether D gets slotted? Yes, it will get slotted. Will it get slotted? No. Why? Because 1 is already slotted. 1 got already slotted. That is, 1 is not 1. 1 will be 0. So 0th slot is already occupied by C. We'll go ahead. This is what we expected. So this loop should work out itself. isn't it? After that, what we do is we print those job sequences. How do we print it? We go from 0 to nth element job, and for whichever slot that is true, only that gets printed from the 0th, right? From the 0th to nth. So we get those results. That's it. Hope you have understood this job sequencing. Thank you so much.